I welcome you to have a session in chemical bonding. A usual question we can see is which of these forms ionic bond or which of this compound is ionic? To answer this question, check the option which has a first group metal and a 17th group element like NaCl, like potassium bromide, or a first group metal and a 16th group element like oxygen, Na2O, K2O, or it can be even a metal like aluminum and a 17th group element. So, usually the first group metals and the 17th group elements or 16th group elements readily make ionic compounds. It seems AlCl3 is a special case. If you put water in aqueous solution, aluminum chloride becomes ionic because the water molecules surround the aluminum and Cl and separate them as Al plus 3 and Cl minus. As so many millions of water molecules surround each fellow, a kind of ionization and their separation is facilitated by water. Therefore, AlCl3 is ionic in water. But in the absence of water, in anhydrous state, AlCl3 is covalent. For that matter, HCl is also covalent because it is made with two nonmetals. But even HCl in aqueous solution will separate into H plus and Cl minus by hydration, so it becomes ionic. Mind you, if any compound has two nonmetals, essentially it is covalent. BCl3 is covalent. AlCl3 has one metal and one non-metal, AlCl3. Though this is a metal and a non-metal in an anhydrous state, AlCl3 is covalent, but in aqueous solution it becomes ionic. Also, I want you to notice first group bottom element, 17th group top element, say fluorine and cesium, they make mostly ionic compound. The compound is cesium fluoride, mostly ionic. The bigger cation, the smaller anion. They favor the formation of highly ionic cesium fluoride. So left bottom, right top, most ionic. Also, sometimes we have compounds like ammonium chloride. The ammonium chloride is so special that it has all types of bonds like ionic bond, covalent bond, a special bond which we see later called day-2 bond. All the three types of bonds are there in ammonium chloride, though it has all nonmetals. It is an exception. Otherwise, usually if a compound has all nonmetals like BF3, it is covalent. If the bond is between identical atoms like in H2, if the atoms are identical as in H2 or as in Cl2 or as in O2 or in N2, notice that these are pure covalent, 100% covalent nature. The bonded electron pair is exactly at the center of two atoms. However, if the covalent bond forms between two different elements, one has more electronegativity, one has less electronegativity, the bond pair actually formed by contribution of one electron each from two atoms, but still the Cl keeps the bonding electron pair close to itself. So it gets a little minus charge, it gets a little plus charge. So it is getting a kind of polarity, a positive pole, negative pole. Hence HCl is called a polar covalent molecule, or this is polar covalent bond. Even in water we have polar covalent bond. It has partial charge separation, not full charge separation. So often they ask a question, how many covalent bonds are there in a molecule like SF6, in a molecule like PF5, in a molecule like C2H6, in a molecule like C3H8. Simple cases. All these compounds don't have any ring-like structures, they are open chain. In simple open chain compounds, as a general rule I can say, number of covalent bonds must be equal to number of atoms minus 1. Here total atoms are 7, 1 sulfur, 6 fluorines. So I have 7 minus 1, 6 bonds. In PF5 there are 6 atoms, 6 minus 1, 5 bonds. They are all covalent bonds, these are all non-metals. In C2H6, which is called ethane, it is a compound that has carbon and hydrogen. It is called organic compound. Such compounds are there in organisms. Ethane, in ethane, how many bonds are there? There are 8 atoms. 8 minus 1, there are 7 bonds. It means there are 7 into 2, 14 electrons are involved in bonding because each bond involves 2 electrons. If I take C3H8, all compounds which have a formula like CnH2n plus 2, they can have as many simple covalent bonds as equal to total number of atoms in the molecule minus 1. In any open chain compound, this formula gives a simple covalent bond, sometimes called sigma bond. Notice that if the electronegativity difference between two atoms is greater than 1.7, if one is a metal, one is a non-metal, then definitely that can make a ionic bond. Whatever may be the electronegativity difference, if both are non-metals, the bond formed is covalent. Look at the total number of electrons available in the molecule. For example, you have a molecule like NO2. Nitrogen has total how many electrons? Atomic number 7. 7 electrons. Oxygen atomic number is 8. So 2 oxygen 16. If you sum up the number of electrons which are there in a molecule, if you are getting an odd electron, this molecule has an odd electron in its structure. Anybody who has odd electron like this is attracted by external magnet, so it is called paramagnetic. If you look at NO, it has 7 plus 8, even it has odd electron. If you look at the ClO2, the Cl is having total 17 electrons. Each oxygen has 8 electrons, total 16. Even ClO2 has odd electrons. Any molecule that has total odd number of electrons, that is odd, that also has an odd electron in its structure, so it is paramagnetic. So if I am given a structure like C10H22, can you guess how many simple sigma bonds it has? But exactly sigma bond you see later on, it is a simple covalent bond formed by sharing of an electron pair between two atoms. Because it has total 32 atoms, it must have 31 simple sigma bonds. Are we clear about it, sir? Also, I want you to notice, if an element in its configuration has only one valence electron, like if it is in first group, like lithium, sodium, potassium, rubidium, it can readily lose electron. Its electrovalency is 1. 70th group element like fluorine, chlorine, bromine, which has 7 electrons in the valence shell, can gain that electron. So you can expect a compound of formula MX. On the contrary, if you are combining a second group element like beryllium, magnesium, calcium, strontium, barium with the 70th group element like fluorine, chlorine, bromine, iodine, the valency of second group element is 2. Valency of 17th group halogen is 1. So you should crisscross, get the formula like MX2, CaF2, MgCl2, like that. So this is a quick review of some questions related to chemical bond.